Hi there, guys. We're looking at upper and lower bounds here, or what's sometimes called limits of accuracy. I'm going to take a question from the Corbett Maths questions, exam style questions here. I'm going to take question 4, and this one is on, what's this called? This one's called rounding the highest and lowest values. So what we're going to do is the reverse of rounding here. So if we look at question number 4, I've just taken it, it says a newspaper says the number of people at a football match is 44,000. This is correct for the nearest 1,000. What is the lowest possible number of people at the match? So we've got a number which is already rounded off. So this one has already been rounded off. And the actual number of people at the football match could be more or less than that. For example, if we say it could be 44,001. 44,001 would round off 44,000 to the nearest 1,000. In fact, we could go much higher than this. We could go 44,081. That would still be 44,000 to the nearest 1,000. Now, there's obviously much higher numbers than that. There's also lower numbers than that as well. So if we went down to 43,999, that would still round off to the nearest 1,000 to 44,000. Now, the question is, what's the lowest possible number which would still round off to the nearest 1,000? So in order to do this question, what I would do is come up with a number line to help us. So we see that we've got 44,000. It's been rounded to the nearest 1,000, so I'm going to underline that place there, and I'm going to do a number line. I'm going to put 3 things on that number line. I'm going to put on 44,000, and I'm going to go up to the next 1,000, so I'm going to put on 45,000, and I'm going to go down to the previous 1,000. I'm going to go to 43,000. Okay, and then what I'm going to do is I'm going to draw a line off halfway in between both of those thousands. So halfway in between those two thousands, we've got 43,500 and 44,500 here as well. So the 500 comes from 100 divided by 2. So it came from the 1,000 because we were doing it to the nearest 1,000. Okay, so now when you look at this number line, you can see that anything between those two halfway points is going to round to 44,000 to the nearest 1,000, and then anything after those points is going to round up to the next one, or round down to the previous one. Okay, so we need to be a little bit careful here, though, because we're talking about whole numbers of things. So when they say the lowest possible number of people at the match, it could be 43,500. So 43,500, we rounded that off to the nearest 1,000. So there's the thousands place. Draw a line off, circle the next place. Is it 5 or more? Yes, it is. So we add 1 onto the 1 in front. So that's just normal, straightforward rounding. The problem is that if we were asked instead for the highest possible number of people at the match, 44,500 would actually round up to the next 1,000. So for the highest possible number of people at the match, we'd actually have to go to 44,499. We'd need to take 1 off this because this number actually rounds to the next place. Okay, so let's just recap this. If we're doing the reverse of rounding here, so we're thinking what's the lowest possible number of people that are actually at the match, what I would suggest we do is come up with a number line, put on the number which has been rounded off, so the rounded off number on the number line, underline the place that it's been rounded off to, and then go up to the next one of those, so add 1 onto the 4 there, the next 1,000, and take 1 off that place. So we've got 43,000 there. So we've gone up and we've gone down in the thousands. Go halfway. Okay, this one, 43,500. That one is our lowest possible number. And later on, we start calling that a lower bound. And then the other halfway point, so 44,500, we'll round up to the next place, but we need to take 1 off that to get the upper bound. So we're going to do 44,500 take away 1 is going to give us 44,499. And that's going to be our upper bound. Now, this technique of taking away 1 is only necessary when we're talking about whole numbers of things. So the next example we're going to look at does not have this extra adaptation at the end. Okay, so the next example is actually going to be easier. Okay, so let's look at another core book maths question. So I'm going to take question 2 here, and this one comes from limits of accuracy. Okay, so it's also the reverse of rounding. It's also about finding what's called the upper and lower bounds. But this one is for continuous data. So for things which you can measure and measure ever more accurately. So not things which land on whole numbers or exact halves or something or other. We're talking about something which can be measured ever more accurately. You can keep zooming in and keep measuring something ever more accurately. We're talking about lengths, we're talking about times, we're talking about weights, that kind of thing. Okay, so not whole numbers of things. Okay, so question 2, just take this one here. So it says the length of a table is 105 centimeters. Now you might think that's a whole number of things. Yes, it is, because it's been rounded off. But the length of the table, if you zoomed in, it might be 105, but if you kept zooming in, at some point you're going to get some sort of error. So that's what I mean when I'm saying that this is continuous data and not whole numbers of people or sheep or whatever it is. Okay, so the length of the table is 105, correct, to the nearest centimeter. So it's 105. The nearest centimeter is this place here. Okay, so write down the smallest possible length of the table. I'm going to do the same thing again. I'm going to do 105 there. And from that place there, I'm going to go up 1. And I'm going to go down 1. Okay, and I'm going to go halfway as well. Okay, so 3 numbers and then the halfway points. So I'm going to go 104.5 and 105.5. And in this case, the smallest possible length of the table is 104.5. So we can just put that down because 144.5 is the smallest number, which will still round up to 105. If you go less than that, it will round down to 104. Now, when it says write down the largest possible length of the table, this is talking about the upper bound. Now, in this case, we can just use this number here. Frankly, the largest number is 105.49999. It keeps going on. But you can't write that down easily in an exam situation. So we just write down 105.5. Okay, so when we're not talking about whole numbers of things, like a frequency, like a number of people, for example, and when we're instead talking about measurements, then it's a bit easier. So in this case, we just say the halfway point here is called the lower bound, and the halfway point up to the next centimeter is called the upper bound. Okay, so we're just going to write 105.5 there. Okay, well, let's look at another question. And let's look at, see if we can find something a bit more tricky. So you can see that this one here, let's just do this very, very briefly. Question number 4 talks about the distance between the Earth and the Sun is 150 million kilometers, correct to 2 significant figures. Now, if you're going to do this one, again, 150 million, let's underline the second most significant place here, which is the 5. And so then when you come up with your number line, you're going to have 150 million. Okay, tell you what, I'm just going to write down here 150 mil. Okay, and then if we go up one on this second most significant figure here, then we're going to go to 160 mil. And then we're going to go down to 140 mil. Okay, now we find the halfway points here. So the halfway point is going to be 145 million, and the halfway point is going to be 155 million, and that's going to be your lower bound, and this is going to be your upper bound. There's the lowest possible value that it could actually be, and the highest possible value it could actually be as well. So that's how you deal with it with significant figures. And let's see if we can find one with decimal places as well. So let's see if they've got one with decimal places. Doesn't seem to be the case. Here we go, this one here. So for this question, for question 12, they say Declan ran a race of 200 meters in a time of 26.2 seconds. The distance of 200 meters was measured to the nearest 10. So there you're going to write 200. There's the nearest 10. So you're going to go to 210, and you're going to go down to 190. Okay, and then you find your halfway point. So there are your lower bounds and your upper bounds. But with the seconds one, it says 26.2 has been rounded to the nearest tenth. Okay, so nearest tenth, 26.2. There's the tenth position. So we'll put on 26.2. I'm going to put 26.3. I'll put 26.1, and I'm going to find my halfway points. So we're going to say 26.15 and 26.25 there. And so this is your lower bound. This is your upper bound. Okay. So then you actually have to work out an average speed, and that becomes a more complicated question. For an average speed, an upper bound of the average speed, you'd need to do distance divided by time. But to get the biggest answer possible, we'd need to use the upper bound of the distance and divide by the smallest possible number in this case. So you'd need to do this number, 205, divided by the smallest possible number, which would be 26.15. Okay, guys, thanks for listening, and good luck with the exercises.